So I don't know when I'm supposed to start. You guys tell me. Now? Okay. All right. Well, hello, everyone. Nice to see you all. So many of you. Did you guys all have coffee? Yeah, man, I should have had a fourth cup. Let me do just a brief tech check. You guys can hear me well? Yes? Is my fly open? No? Great. All right. So, my name is Enrico Campidoglio, and I work at Triton 37. And today, I'd like to talk to you about how to write minimalistic tests. I assume you guys are familiar with unit testing. And if you're not, well, you will be after this session. So I said I work at Triton 37, where I split my time actually between two roles. Half of my time is spent being a consultant, while the other half of my time is spent being a programmer. Yeah, that's me when I was young. Good times. Good times. So, AutoFixture. Let me just ask you a brief question. How many of you have heard of AutoFixture before? Okay, so that's quite a bunch. I'm surprised, but pleased. I'm going to assume that you guys are all .NET programmer. Let me also ask how many of you are C# programmers? Okay, that's almost of you. Any Java programmers? Oh, that's good. Yeah. And any Bob Dylan fans? Okay, so you guys should have come to Leadspeak last year if you weren't in Stockholm, because Bob Dylan was having a concert at the same venue where we had Leadspeak. So his band was rehearsing later in the day. So you could actually hear Bob Dylan at the same time as you had the technical content. So it was like the best of two worlds. So today, we're going to write small tests, small unit tests, but still expressive tests. And we're going to do it with, by leveraging anonymous data and AutoFixture. More concretely, we're going to implement the first rule of the game of life. Anyone familiar with the game of life? Okay, so that's half of you. Basically, the game of life is a logic game or a mathematical game. I'm always not sure, and every time after each time I give this presentation, I never check it on Google. So I'm always wondering. So it's basically a game that consists of a grid of cells. Each cell can either be alive or dead, so it has two states. And the game is about refreshing this grid by recalculating the state of those cells, basically, according to 4 rules. And we're going to implement the first one of them using TDD and C#. Did you say TDD? Yes, I said TDD. Not dead. Yet. So, what is anonymous data? Let's play a little game. Now, picture in your head anonymous data. Give it like a few seconds. Anonymous data. Anonymous data. Did you guys all have a picture in your head? Anonymous data? Was it this picture? No? Good, because this has nothing to do with anonymous data. But that's what I thought about first time I heard it. Anonymous data is data that you simply don't care about, but as long as it exercises the paths through your code that you care about. So when you're doing tests, you basically want to exercise a certain path through your code, and that path could be executed by giving it a few different kinds of inputs. You don't care what those values are as long as the path is being executed. So that's anonymous data. That you don't care about. But first, let's look at what are we trying to solve here. What is the problem? Because we always start by having a problem, right? We have all good intentions, but sometimes we just have too much enthusiasm. So when you write tests, you need to set up some kind of context, all right? So context, that context is even called, if you are fashionable, you will call it a test fixture. And basically, what a test fixture is could be that you have to put your application in a certain state in order to test it, or you might have to come up with some input to give to your class or object. In any case, this fixture is basically all the things. Fixture all the things. The things that you need to put in place to run your test. So that's what we call a test fixture. And that's all nice and all fine and dandy, but you have to create that fixture for each and every one of your tests manually. Do you recognize this? You know, the arrange, act, assert of your tests, the 3 phases, which one is the biggest of those 3? Suggestions? Yes? Arrange, yes. That's the big one. So you have like arrange and then act, assert. So all the tests are like that. What we want is to minimize that arrange by only mentioning things that we care about in the test and nothing more. Let's get rid of the craft. Because, you know, those contexts, they tend to explode at some point. And that's what we call test enthusiasm. You basically want to set up your system in a way that's perfect for your test, and then you're creating objects left and right and putting values in them. But you know, those things get out of hand, and soon your tests start to look like that. You know what we call this? We call it the wall of test. Pun intended. And as soon as a change request comes, you think you have a good set of tests. I know you are not looking at me right now, right? I can actually poke in my nose. Nobody will notice. So you think you have a good set of tests that will make you move fast and handle requirement. Yes, new requirement, new user story. I have all the tests, but then the reality kicks in, and you can get surprised. Oh, splash. Let me introduce you to 3 concepts, because all good things are 3. First one is called equivalence set. Now, yes, yeah, I know. There isn't actually no better way of calling this. What is an equivalence set? It's basically, given the path through your code that you want to exercise, we said there are a bunch of values you could use. Those values that exercise the same path are called equivalence sets. So let's make an example, right? So let's say you have this pretty code. Now, we're checking on an int, and basically we're saying if the value is bigger than 3, we do this, otherwise you do that, okay? Do this, do that. If I call fork with 4 and 9, I'm going to exercise the first part of the test. If I call it with 0 and 2, bless you, 0 and 2, then we will do the other one. Easy, okay? So we call those 2 groups of values equivalent sets. Because you don't care if it's 4 or 9, it will only execute that part. You're all with me? Yes. All right. Second concept, the Pareto principle. Now I know if some of you have kids, you might recognize the word Pareto because it's the dog in Dora the Explorer. But this is not that Pareto. It's another Pareto. This is the Pareto principle. Pareto principle basically says 80% of the effects of something are caused by 20% of the causes. Okay? So that is famous 80-20 principle. That's the Pareto principle. How do we apply it to tests? Of all the equivalence, of all the code paths, or most of the code paths you have through your code, let's say 80% of them, you can run them by using 20% of those equivalent sets. Let's take another example. So let's say we have this code. Oh, is it the same code? Almost, yeah. If I'm asking you to think of a number, chances are you're going to give me a positive small integer, right? Think of a number. Is it between 0 or maybe between 1 and 100? How many of you get 1 and 100? Yeah, it works. However, if you're a programmer, you will give me a number between 0 and 255. So, often, if the test required an integer, giving a small positive integer would be enough to exercise most of the code. All right? So we don't need to come up with fancy values to execute the code. It's enough to give a small integer. And that's the Pareto principle. 20% of all the possible values are enough to exercise most of the code. The third principle is called the test data builder, because given these two principles, you can exercise most of your code with a few values which you don't care about what they are as long as they execute that code. Why don't we let someone else create those values for us, instead of having to come up with them ourselves? So that's called a test. It's a test data builder, which basically is like a fancy name for a factory that will give you objects to use in your tests that are ready to use with some good enough values, okay? And in 80% of the cases, the default values that the test data builder will give you will be good enough. So you don't have to do anything. You just run with your tests. For the 20% of the cases, it's nice to have this 80-20 rule. Then you will need to tell the test data builder, in exactly this scenario, I want you to give me a value between this and that, okay, a certain range of, I want this string to be that value. So for corner cases or special scenarios, you need to have some kind of customization API, so that you can tell, in this case, I actually care about what the value is. Okay. So what is AutoFixture then? AutoFixture is basically a test data builder, which will give you good enough data for your tests and will allow you to minimize that range phase. So let's look at some examples, right? Because, talk is cheap. Show me the codex. All right. So I promised you I'm going to do it with TDD. So it's going to be a little bit awkward, because you guys all know that TDD gets awkward already when you do it yourself. Imagine doing it in front of an audience. But bear with me. So we said we're going to implement the first rule of the game of life. Now, the first rule of the game of life says, if a cell has fewer than two alive neighbors, then, and is alive in this generation, it's going to die on the next one, because it's called underpopulation. So that's what we're going to implement. So we start with the test. I'm using XUnit here, but it doesn't really matter. And we're going to write the first test. Now, TDD purists, I know you're out there. Which test should I write first? I'm open for suggestions. No, I'm not. But still, it would have been interesting to hear. So the first test is, it should return a generation containing some cells. So we need basically to create our objects, and we make sure that when we ask for the next generation of cells, we actually get some cells back, right? So let's do the arrange, act, assert dance, shall we? Arrange, or given. What do we have here? We're basically creating this generation, which consists of a list of cells. Those cells have coordinates because they are on a grid, X and Y. And that's our seed. That's our first generation. Then we create a grid, and we're going to ask the grid, refresh it, give me the next generation. Apply the 4 rules of the game of life, give me a new generation back. So that's our act. What do we assert? We assert that the next generation should not be empty. Fair enough? Okay. Of course, if we run this, we get all red, because we don't have anything of those things we mentioned there, right? We have no classes. Okay? So let's go and implement those classes. So first class we're going to do is called the grid. It's actually what our system on the test. Second class, we're going to do the generation. And the third class, we're going to do the cell. Is it okay? Oh, let me get rid of that white space. Tabs or spaces? Okay, how many of you have tabs? Okay, that's about half. How many of you have spaces? Okay, that's not the other half. What do you guys have? You have a mix? Ah, okay. Oh, nice. Unicode is this one, yes. All right. So I use spaces. But as I'm a consultant, sometimes I have to run with tabs. You know, we consultants, we don't get to choose. So, first method, we're going to implement a refresh. I forgot to ask you if you can read that font size. Can you read the font size all the way to the back? Yes, I see nodding. Okay, I see thumbs up even. Okay, so that's the first, that's our stub basically. That's the method we are calling in the act. Now let's implement, I'm sure when you program in TDD, you also do like that. Computer, give me a constructor that takes an enumerable. Done, boom. That's why TDD is so popular. Oh, give me cell, X and Y. Nice and immutable. Yeah, and I'll have a coffee with that. So let's try to run the test. Okay, so now we have a different test results. Let me highlight it for you. This is interesting. Object assertions does not have a definition for not be empty. Okay? So here, we are actually treating this next generation as it is a list in itself, which is kind of nice, you know. So let's go ahead and implement an enumerable here. So our generation is actually going to be an enumerable cell itself, so we can treat it as a list of cells. Now computer implement get enumerator. And actually ReSharper can do that. This particular case, it will help. All right, so now we run the test. Let's see what we say. Ooh. Expected not to be empty, but found null, exactly what we expect. So, again, TDDers. What is the least amount of code we need to write to have this test pass? And don't tell me return seed. Yes, I knew someone would say return seed. Not yet, not yet. No, we need to test drive this thing. So, I don't know if you guys have read about it, but a few months ago, maybe it was even a year ago, Robert C. Martin wrote a blog article called the Transformation Priority Premise. How many of you guys have heard that? Transformation Priority Premise? Okay, a few. So what's his theory was, is that when you do TDD, the way you transform your code, when it's driven by test, it goes from very specific to more generalized. So you go through these phases that have a priority. The first phase is basically you write a constant value just to make the test pass. And then you progress by introducing variables, and then you introduce expressions, and then you introduce method calls. So that's how you progress as you test drive. So our first step will basically say, let's just return a new generation. And in that generation, let's just add this list of cells with exactly one cell, and we don't care about what the coordinates are, okay? Oh, what happens here? Some invalid. Can you guys see anything I'm not seeing? New generation. Curly brackets. Where? Tell me the line number, which I removed to make more room for my code. Oh, yes, thank you. Thank you very much. Yes, and then I, of course, have to do this, right? Yes. Test passed. First green. Let's skip the refactor part, it's not important. So, first test. Okay, second test. Second test. Is it fair enough? Should return the same amount of cells. If we give it X amount of cells, we expect it not only to be empty, but also have the same amount of cells. No cells to be either removed or added. They should just change state. Okay, so given. This time, just to make it a little bit different, I give it 3 cells in the seed instead of 2. Okay? Just to, I don't know why. Makes sense. Sounded like a good idea at the time. So we do the when, of course that's always the same, and then we do the then. Then. So we give 3 cells in the input, we expect 3 cells back. Easy. Do we pass this test? No. Of course not. You guys, you guessed it. Expected 3 items, but there was only 1. So now I'm gonna follow your advice and say, okay, the easiest way to make this test pass is basically say return seed. Correct? Yes. We went from a constant, something we created in line, an object, to a variable. From very specific to a little bit more generalized. And now we're going to make the third test. Now I'm going to make a whole bunch of them, because it gets kind of tedious after a while. So that's actually the first rule of game of life. If I have a generation with 1 cell, solitary cell, it has no neighbors, and it's alive, when I refresh it, that cell should be dead. And now it gets interesting. So now I want to create a new cell. I give it X and Y, and I have a new property called alive, true or false. And I'm creating a generation with only that cell. So it's alive, and it doesn't have any neighbors. That's our scenario, that's our fixture. Oh, too much enthusiasm. 2, 3. So when I refresh it, then that solitary cell that I sent in should have the state set to false. Guys still awake? Thanks, great. I know because these code demos, they get a little bit dry, you know? Okay, so let's run the test. Maybe I should, no, I have a much more tempo. Okay, cell doesn't have a constructor that takes 3 parameters. Oh, no, it doesn't. So let's add that. Let's add a bool, let's call it alive. You guys noticed something, right? Don't tell me. I want to find out by myself. Oh, more red than I expected. Okay, so I introduced a new parameter in the cell constructor, and all the other tests are broken now, right? So how will you solve that? Yes? Man, resharper, yes, but this is Sublime. Thanks. Let's make it optional. Unless JetBrains wants to release a plugin for Sublime, that would be nice. Now you might ask yourself, why am I using Sublime? But that's a whole other story. Okay, so now we add a default, make it default value, and now we get exactly what we expect. Expect it to be false, but the cell was still alive. So we didn't implement the rule. How will you implement the rule? Now look at this code. Watch me. Watch me do that. Now we know that we sent in only 1 cell, right? In this case, when we are doing the where is the equal? When we do this rule. So I'm gonna do this. Yes, you can't stop me. I'm gonna get the first one. Because in the third case, we expect only 1 cell to make the test pass. Let's get the first one. And it's not over. If you guys are cringing, let me do this. Yes, mutating state. I see people going like that. Oh, man. Yes, it's TDD. We don't get to the refactor part, yes, yet. So is this enough to make the test pass? Oh, hell yeah. Okay, so let's stop here. We're not going to implement the entire algorithm, right? But we have driven our naive implementation, but that's what it is. The naive implementation is driven by tests. Let's stop here, because actually we are not going to, the point of this demo is not to look at the code itself, it's to look at the test code. So right now, we have a bunch of tests. Let me just do like that. It's not really important what's over there. We have a whole bunch of tests. Boy, are those some ugly looking tests. Don't you agree? Yes, I've seen worse. Yes, I did too. This is after all a demo. But there are some problems in this. Let me go through them. So, what are all these values? Why 9 and 12? They're not even close to each other. Does it matter? Well, I don't know. So let's pretend that I'm a programmer. Well, actually, I'm a programmer. Let's pretend that I'm new to this code base, and I, go and look at it, and I see all those values, and I start wondering. Then I also wonder why 2 here and why 3 here. Is there any particular reason? Oh, why 3? What happens, for example, if I add another cell? Hell, let us be brave. Let's make a cell with exactly the same coordinates as another one. And I change this to 4. Does it still pass? Oh, okay. So it doesn't really matter, okay? Lots of questions, very few answers. Here, also, cell. Well, this one I can get I kind of get. However, I don't really like this implementation. It's very verbose. Why should I create a list and pass it in? Wouldn't it be better if we use the params, right? The params keyword in C#, so that I can send in a cell or more or no cells, and it will still be fine. So you know how you do the refactoring? The first thing you do when you're a consultant, you get into a new code base and you start refactoring. What's this crap? Let's remove that. Remove this, remove that. I'm just kidding, of course. So let's refactor this because it fits my taste better. No, this is much nicer. Let me run the test. Oh man, that kind of deflates me. Now I only have 3 tests, so I could actually go and fix them. What if I have 2,000 tests? Now I become a sad panda. So I had all good intentions, but no, those tests are stopping me from making refactoring the code to be better. So you know what? Screw that. Sorry. I'm off to the beach. I won't refactor anything. Oh, still okay. So I'm actually tests now are a burden. They are like walking in concrete. Okay, so there are a few problems. You all agree on that, on those tests. How can we leverage, which is a nice word in itself, how can we leverage those principles we talked about? The equivalence sets, we saw the coordinates are not important for the test, yet they're mentioned. Having a list with 2 or 3 cells doesn't matter, yet it's mentioned in the test. And calling the constructors directly creates coupling. It doesn't really matter for the tests. So how can we leverage a test data builder to create those test objects for us instead? So let's start using AutoFixture, because of course you could make a test data builder yourself. Like for every production code class you could have a method called build or create a test object that creates that object in a good enough state. You could do that by hand. But we have reflection, so why not use that to automatically generate objects and fill them with values that are good enough. So let's start by importing our namespace. And now let's do this. Well, first let me run it again. Yeah. Let's do this. Now let's ask an object called fixture, a variable called fixture. Let's create a new generation and create a new grid for me. Now, of course, the fixture is our entry point for the test data builder. So we need to create one fixture class, which is the entry point, and then you basically ask the fixture, give me an object of this class, and fill it with values. I don't care what they are. Does this work? Oh, yeah. Nice. So now I go all crazy, because I can start refactoring. Oh, notice also that I create a subject on the test with AutoFixture. I don't have to create it by invoking the constructor. So let's do it here too. Does it still work? No. So, okay, why not? Let's look. Silence. Surprised. Why not? Can you guys read that? I expected 4 items, but got 3. So it seems that if AutoFixture, or the test data builder AutoFixture in this case, sees that an object requires a list of cells, it will give me 3. Why 3? Why not? It's an arbitrary number. Okay? However, you shouldn't care. You shouldn't care how many cells there are, as long as there are a few. So we can't assert on having exactly 4 here, right? What we should assert, it should have the same count as the seed. Nice. So now the test is more generalized. We are not asserting that it's exactly 4, as long as it has the same count as the original one, which is basically what our test is saying. The same number of cells have the same count. Okay. Now it gets a little bit tricky, because in this case we actually care about how many cells there are, and we care about the state of this cell. So we can't just say create a bunch of cells. We need to be more specific. So how do you do that? Remember, this is the 20% of the cases where the good enough values are not good enough. So you need a customization API to tell the test data builder, you need to give me objects in these states. How do you do that? What you do, lots of code. What you basically do is say, fixture, customize the cell. So every time it needs to create a cell, basically, customize it by giving the alive property the value true. Okay? Not only that, but also every time we have to create a sequence of cells, whether it be a list, an enumerable, an array, whatever, a list of cells, put only 1 in them. Only single element sequence. Give me all sequences of cells with just 1 element in. So I've customized the algorithm a little bit. And then after I've done that, of course, I can still ask to give me those 2. And run. Doesn't work. Why? Well, it doesn't work because I don't have this object anymore. I don't create it myself. So I can't assert on that. However, I'm telling here that every time I see a list of cells, it should have exactly 1. So I should be pretty safe in saying that the seed should have only 1. Right? Okay. So now we have refactored the tests, which in itself is a pretty exciting exercise. Because the first time I thought about it, it's nice to have a test as a regression when you do refactoring of your code, but if you do refactoring of your tests, how do you make sure you didn't break anything? Do you have tests that test tests? Then someone pointed out to me, no, your code is your safety net, because it's just changing the tests, not the code. Heads exploded. So as long as you don't change the production code, you can refactor the tests. And if they still pass, you didn't break anything. Genius, genius. So what we are doing now is that we are actually refactoring the tests, not the code. Well, actually, yes, let's refactor the code a little bit. Remember that refactoring I wanted to do before? Do you think I can do it now? Can I do my params thing? Nice. Because I'm not invoking the constructor explicitly. I'm letting AutoFixture invoke the constructor. So I can refactor. Now let's say a new change requirement comes in. For example, like if I really want to implement this rule, I have to introduce the concept of neighbors, because cells has neighbors, and they have to check the state of the neighbors to decide if the cell is alive or dead. So at some point, I might have to introduce, for example, an int that's called neighbors, right? So I'm actually adding a new parameter. Does it work? No. Of course, because this must be last. But I don't actually need this anymore. Can remove that. Does it work? Yeah, refactoring, adding features. Yeah, because I don't have the tight coupling on the constructors, and I don't have even the tight coupling on the properties. I can, of course, add neighbors, which is a value. I know it's misspelled. And then, and then I can even add, let's even this one. And AutoFixture is going to put values in those because they're public and they're writable. Okay? So why not? Let's put a value in them. Nothing's going to be null by default. So it's nice to be decoupled from the details when they don't actually matter for the test. So you might argue that this is a little bit more, it's less, because less is more. It has, the given is a little bit shorter, and we're not mentioning things that don't really matter. However, I think, sorry for the scrolling, I think we are onto something here. Here we are actually customizing to create one generation with one alive cell in it. What if we want to reuse that in other tests? Because that's the kind of scenario you might want to have in different tests. Could we extract that and have it as a separate customization class, for example, which you can just plug in different tests? We can do that. So let's create a new class. And this class, well, let's first add the namespaces, and let's call this class single alive cell customization. Okay. Oh, twice. So let's call it single alive cell customization. This is basically telling me that I want to customize the creation of objects for having just one cell and have it alive. So I'm just implementing an AutoFixture interface, which luckily only has one method. It's called customize, where you get the fixture in, and then you can do whatever you want with it. You can set it. You can use the API to customize it. So let's just take those two away from there, and let's put them in here instead. Okay. What we do here is basically we say fixture.customize new single alive cell generation. Does this work? No. Single alive cell generation. Why didn't you tell me? It's called customization. Oh, didn't you tell me now? Still working. So we basically extracted this customization part and have it as a separate class, which we can reuse instead of duplicating the same code every time. So that's even better. But we can do more. So there are a few test runners that have the concept of parameterized tests. So your test method can have parameters, which are used in the test, and then the test runner will basically run the test with multiple values for those parameters. Are you familiar with the parameterized tests? So a few of you are. So XUnit has it. They are called data theories. NUnit has parameterized tests. Even MSTest has parameterized tests. And MSTest goes actually one step further. You can read those values from a database, because you want to do that in unit tests, of course. So XUnit has this concept. Now, what AutoFixture can do is actually take advantage of those parameterized tests. So instead of explicitly, imperatively ask the fixture for values, why not just declare it in the signature of our test as parameters? So in this case, we need a generation, and we need the grid, which is our subject, okay? So we don't have to do this. We're basically declaring that we need those two values. Now, of course, we need to change this into a theory and import a different namespace, because it's, of course, in another one. Extensions maybe, yes. And then AutoFixture also has it in another one. So AutoFixture has an optional binding to XUnit. AutoFixture works by itself, but if you want to use this feature with XUnit, you need to have another assembly that contains the glue code. And XUnit has those theory in another namespace. So we're basically just adding some import statements over there. We are transforming this into a theory. However, we also need to, because what happens when you have a theory? XUnit is going to see that this test needs 2 parameters. Which values? What values? We need to either provide values with an attribute, or we use an AutoFixture attribute that's called AutoData, which basically tells XUnit every time you need to provide values for parameters, ask me. I will give you the values. Does this work? Yeah. So now I'm going from an imperative model to a declarative one, which makes our test even smaller, arguably. So of course we can do the same here. We can say generation. The C, then we can have our grid subject. Theory. 8AutoData. It's a funny name though. AutoData, AutoFixture. It's like my auto needs some fixture. It actually really does. Oh, sorry, I have to remove that, of course. Still going, I like green. Now this one becomes interesting because actually we are calling the customization API. And this gets a little bit philosophical, but I will spare you the details. So what we need to do here is that when you use this declarative model, the only way you have to customize the fixture is by making an attribute that uses a customization. So what we need to do here is to make a special attribute that basically activates these settings for us. So let's make a new class, and let's call this class single alive cell, not customization, but just let's call it attribute. And let's import the necessary statements. And let's call this single alive cell attribute. Let's inherit from the AutoData attribute, which is the one that is by default in AutoFixture. So what do we do here? We basically, we call the base constructor of the other one, and we create a new fixture in that, which we customize by passing the single alive cell customization. So we basically make an attribute that invokes the base constructor, which needs a fixture, and we give it a fixture that's already being customized with the right customization. Okay? Let's see if this compiles. I think I'm going to change something over here. Single alive cell generator isn't the same? Ah, thanks. Okay, this is compiling. So what can we do here? We can actually remove this and instead use our attribute. Let's change this into theory. And let's use our single, why do I come up with those complicated names? Single alive cell. Yes, we don't have to use the word attribute. So let's declare our generation seed and our grid subject. Yes. Yes, yes. Let's do that. Will it blend? Yes, it blends. It even flies. Okay. So now we have reduced our arrange phase to basically nothing. But still, we're only mentioning things that we care about. In this case, we don't care about nothing, but we're asserting that the generation is not empty, and it has the same count as the one I get in. So we are testing really what's really essential here. And here we're actually customizing our scenario, our fixture, saying I want one generation with one cell, and that cell must be alive, because then in that case, I can make sure that in the next generation it's dead. So let's go even one step further. Let's get rid of those. Oops. Which one was it? I wanted to just indentation. That's all I want to do. Please. Yes. Look at those tests. Oh, of course you don't need to create a fixture anymore, right? Do you still pass? Still passing. Let's even compress this even more for effect. Let's remove all the white space. Okay, so let's do a little bit of comparison with our original test, which let's put it over here. So, I don't know about you guys, but if I have to, like, I don't always maintain tests, but when I do, I like them like the one on the left. Yes. My right, your left. Okay, so that's basically what we have done. Let me check on time. How long, when did we start? I have until, we start at 11. Are you telling me I have 20 more minutes? I have 10 minutes. Oh, okay. Let's see how much I can do in 10 minutes. Because I have a little bit more I can do in this code, but I have a little bit more slides too. Let me think. 10 minutes. Now, let's do the slide first, and then let's see if I have more time afterwards. Okay. So, what I want you to remember from this session is basically this. When you're writing tests, make sure that you only mention things you care about for your test. What you usually do in tests is that you have to create all this context in order to be able to test your class. However, that context doesn't have to be very big, because what you really care about often is one thing. So let's use a library, or let's create a test data builder ourselves that is able to create objects in good enough states as long as they exercise the path through our code that we want to test. And let's not mention things that we don't care about. And also, that will reduce the coupling that our tests have to the production code, which will enable us to be a little bit more flexible when we do refactoring. Also, we don't want to have magic values in our test if they're not relevant. We don't want to have constants if they don't have a meaning, because they create misunderstandings. People will think that those values are meaningful. So no magic values. Reduce coupling, test only what's needed. Don't mention anything more than that. They will have tests that are smaller and easier to maintain. Okay? So that was quick. I actually have a few more code to show you. So this attribute here is called single alive cell, creates one generation with one alive cell. But what if I want to be a little bit more flexible? Sometimes I want to create a generation with one cell that is dead. Do I create a whole new attribute? I don't have to. In this case, I could actually make this into a parameter. So I can customization with few parameters that allow me to customize the customization inception. But it allows me to reuse it in different scenarios. It doesn't have to be true here. So what do? We create a constructor, single alive cell customization. And in that constructor, we're basically saying, let's get the state in the constructor instead, right? So we don't even have to call it single alive cell. Let's call it single cell. customization. And let's save it into a field. Do you guys use this or not this? Yeah. Just curious. So let's save it like that and then say alive. Yes. All right. So we're basically having a little parameter in our customization. Of course, nothing will compile right now because I broke everything. I even renamed it, and I don't have resharper. So let's change our attribute. Let's call it. Let's change a lot of things at once. Why not? Let's change more. Oh, that's a good time to ask me if I want to buy Sublime. It's like, I notice you're using Sublime in a presentation. Maybe you should consider buying it. True. I'll do that afterwards. Single cell attribute, yes. Of course, this also needs a parameter, bool alive, which are going to pass on to the customization, which is called single cell. Parentheses expected. I'm going to put one here. Oh. Ah, yes. Why if I double click here doesn't lead me to the right place? And why am I not doing that? And you tell me now? Is this not Visual Studio? No, the reason I actually wanted to use Sublime is a little bit of an experiment, because there has been some conversation about what if, what if? Do we need the elephant Visual Studio? Could we be a little bit more lightweight? No, easy going, like JavaScript? Guys, use Sublime? We would also want to use Sublime. Is it possible to do .NET development using Sublime? Yes, but it's not nice. It's not as nice. We want some kind of IntelliSense, and having it run like that requires you to write MS build scripts and everything. So, but for a demo, I think it's good enough because it's lighter weight. If I had run those tests as often with Visual Studio, we would be halfway through my demo now. Because it's like, okay, I'm running the test. And crunch? True that. Programmers they always have answers for everything. It's true. If I had crunch, then it would just run them in the background for me. Yes? Yes, let me just fix it because right now I can't sleep because my tests are broken. Hold that thought, and I'm just going to fix that so I can move on. So single cell, and I'm going to even use named parameters to make it even more clear. I still have this expected. Where is it? It's here. One more at the end. Seems legit. Why? You know what I'm going to do? I'm going to copy and paste this one. Yes, yes. Thanks. Okay, so now I can move on with my life. Everything is working. I have a customization which even more generalized. I can reuse in more cases. Question? Yes. Absolutely. Yeah, there is one special kind of customization. Now I don't have IntelliSense, so I can't really remember where it is. But there is one called composable customization. And what that customization takes, it takes in the constructor an array of customizations, like params. So what you basically do is that if you would create a customization, where should I put it? I put it here. So you basically say you want to combine, and you say, actually, if you combine multiple customization, you are actually creating a convention for your tests. So you might even want it like game of life conventions. You inherit from let's call it composite. It's something like that, customization. And what do you get? Ooh, Java style braces. In that constructor, game of life customization, you basically call the base can't stand it. You actually call the base that is in the composite customization, and you basically say new single cell customization. True. And you can say comma, new foo customization, and whatever. Because this constructor takes a params of iCustomization in. So you can basically send in a list, and then you can just use the other one. Okay? Composable. I even have time for more questions, right? How much, how long do I have? A few minutes? Talk to me. Wrap it up? Okay. So, with that, I'd like to say thank you for your attention. And if you have more questions, catch me in the corridor or in the big room over there, and enjoy the rest of the conference. Thank you.